Hello everyone, my name is Sadashiv and this is my submission for Sprint 12, the real-time chat application that is built using React, Node.js, Express and Socket.io. So in this sprint, we focus on event-driven architecture and web socket-based communication for low latency messaging. So on the screen, we have the application in the browser where it represents an independent client with its own WebSocket connection, socket instance to the server. If I go to inspect and network tabs, and let's say I reload the page, we should see the socket being assigned to the backend. This is where the backend sits in the header. And I can also show you the logs that are being created in the backend. So it says over time, if I connect from here, let's say Sadashiv and we join chat. So this should give us a connected message. Let me refresh that quickly. And next, we have two rooms, general and tech support. Both of these are isolated completely. And let me open it in the other tab as well so that I show you what this looks like. Before that, when I join room, a join room event is emitted in the front end and backend handles it using the socket.join function. So this implements socket.io room-based architecture, enabling logical segmentation of users. So we have room isolation as well. I mean, if I type something in general, I shouldn't see that in tech support. So this shows that messages are not shared. And also if I try to open a new tab and let's say I join it from here, so I see that it is not same over here. Even if I log in as Bob, we shouldn't see any previous message. This means the rooms are completely isolated. So yeah, but we have a message over here that Bob has joined, right? This is handled using the API request that is made, and both users can communicate now in the same room. Let's say I say hi, so we should have the message being received in the both chat rooms simultaneously. If he says hello, I should get the message over here, right? So this shows the scoped broadcasting, ensuring no cross-room leakage. Now, when I type, React captures this input via onChange event, and it updates the component state, and the UI it renders instantly. I say there, and this is how the control components and virtual DOM reactivity is implemented. We also have something called as typing indicator. While typing, let's say I get the typing indication over here. So the event typing is emitted the moment I press any key in this area. Server broadcasts it to other users using socket.to roomid.emit function. Right. This is all possible because of socket.io. This is a real-time event propagation excluding sender. Right. When I send a message, try to say hello again. The server listens, the front end emits the send message, and the server listens and processes, and it broadcasts using socket.io again, right? This uses full duplex WebSocket communication, avoiding HTTP pooling. Next, we have message rendering. Message is added to React state array and UI updates automatically. And this each message includes sender, content, and timestamp. So this project, if I go to tech support, I see that I have got a message that Bob has left the general. And until anyone joins the tech support, they cannot see the messages being notified or being shown prior, which means the messages are not being shared. So the moment new joiners enter the chat room, we have the chat only for them. So this project helped me understand WebSockets and real-time communication. I also understood the room-based scalability, how the front-end state management happens, and asynchronous event-driven systems. Overall, this reflects how real-world apps like chat systems achieve instant scalable communication. Right. Thank you.